Welcome to tonight's video on Unit 4, Part 2, talking about piecewise and algebra of functions, or as we refer to, combination of functions. A couple things in the notes up here. Number one, it talks about if you're finding the sum of two functions, or you're finding the difference of two functions, or the product of two functions, that the domain is just the intersection of the two domains. The only difference is if you're dividing the two functions, it's the intersection, but you also have to keep in mind that the function in the denominator cannot equal 0. So for example, if you look at number 1, it says to first find the domain of f. Well, the domain of f is the fact that, first of all, you have 1 minus x has to be greater than or equal to 0. So that means negative x has to be greater than or equal to negative 1. X is less than or equal to 1. But also, I know that x cannot equal negative 2 because that would make the denominator 0. So the domain of f would be from negative infinity to negative 2 union negative 2 to 1. So that's the domain of f. The domain of g, the square root of x, that just is greater than or equal to 0. So the intersection, the domain of f intersection g is, well, if you map it on a number line, that might help you figure it out, even though you don't have to. Sorry. So here's 0. So basically it goes from negative infinity to negative 2, and then from negative 2 to positive 1, and then the other one goes from 0 to infinity. So notice it overlaps right here between 0 and 1. So for part B, it says to add the two functions together. So that means you're going to add the square root of 1 minus x over x plus 2 plus rad x. So that means you got to get a common denominator to combine them, plus the square root of x times x plus 2 over x plus 2. And you can leave it like that. So then the domain of f plus g is between 0 and 1. So for part C, now we're subtracting, so we're going f minus g of x. So that's going to equal, so basically it's the same except now we're subtracting, so it's 1 minus x minus the square root of x times x plus 2 over x plus 2, and the domain of f minus g is from 0 to 1. So for part D, it wants to know what happens when you take f times g of x. So that means we're going to multiply the square root of 1 minus x over x plus 2 times rad x. And notice you can multiply under the radical, so you get the square root of x times 1 minus x over x plus 2. So you get the square root of x minus x squared over x plus 2. The domain of f times g is still from 0 to 1. Now for part E, when you're going f divided by g of x, so you're taking the square root of 1 minus x over x plus 2, and now multiplying it by the reciprocal, so now it's 1 over x. So notice you get the square root of 1 minus x over the square root of x times x plus 2. So to rationalize the denominator, you have to multiply by the square root of x. And you get the square root of x minus x squared, because you can multiply these underneath the radical. And then here you get x times x plus 2. So it's equal to the square root of x minus x squared over x squared plus 2x. And notice the numbers that make this equal to 0. Here we know, besides it being between 0 and 1, we know that x cannot equal 0 and x cannot equal negative 2. So since the domain was between 0 and 1, including both, now we know for the f over g, it does not include 0, but includes 1. All right. For number 2, the domain of f, well, for part A, the domain of f is greater than or equal to negative 1. The domain of g is all real numbers. So that means the domain of f intersection g is from negative 1 to infinity. So for part B, when you go f plus g of x, so f plus g of x, so when you add the two together, you get the square root of x plus 1 plus x squared, where the domain of f plus g is from negative 1 to infinity. For part C, f minus g, so it's going to be the square root of x plus 1 minus x squared, where the domain of f minus g is from negative 1 to infinity. And then for part D, it says f times g, so it's going to be x squared times rad x plus 1. The domain of f times g is still from negative 1 to infinity. And then for part E, it's f divided by g of x. So it's the square root of x plus 1 over x squared. And now one thing to keep in mind is that x cannot equal 0 here. So therefore the domain of f over g is from negative 1 to 0, union 0 to infinity. All right, talking about piecewise functions here in the next part. So in the next part, the function that's defined by x if x is greater than or equal to 0 and negative x if x is less than 0, that is better known as the absolute value of x. Because if you graph this, well, x is greater than or equal to 0. It's x if x is greater than or equal to 0, so that means you have 0, 0, 1, 1, and then it just keeps going up 1 over 1. And then it's negative x if it's less than 0. So you have 0, 0, but then you have negative 1 and positive 1. And then you have negative 2, positive 2. So notice it goes like that. So that's how you get your v for that graph. All right. Remember to graph piecewise functions. You go each part separately, and the most important part is the changing point. The changing point is the most important part. So first, it might be a good idea to figure out, well, what is it at the changing point? So for example, if I put 2 in for x here, I get 5 for y. If I put 2 in for x here, I get 2 for y. So graphing the first one, I start at 2, 5. And then if I put 3 in, I get 10. And then if I put 4 in, I get 17. So it's going to be a parabola that goes up steeply like that. And then for the second part, well, 2, 2 is going to have an open circle because it doesn't equal 2. And then if I put 1 in, I get 3. Sorry, I didn't put it precisely at 2. I put it at 1. Oh, I didn't put that right. Sorry, let me draw this again. So 2, 5 would be right here. So it's going to go up like that. 2, 2 would be right here. And then 1, 3, and then 0, 4. So the line's going to go like that. So there's your piecewise definition for the graph for number 3. Number 4, it's a little more complicated. First of all, this should be greater than 2, not negative 2, because negative 2 would make it a negative number there. So if it's greater than or equal to 2, so 2 is 0. Then if I put 3 in, I get 1, but then the square root of 1 is 1. But if I take the opposite of that, I get negative 1. If I put 4 doesn't help. If I put 6 in, 6 minus 2 is 4. The square root of 4 is 2, and then negative. So notice, I keep putting the y values in the wrong spot. Should be negative 1. 6 would be negative 2. So notice the squared function goes like that. Now between 0 and 5, well, first of all, if you factor x squared plus 2x minus 3, you get x plus 3 and x minus 1 over x plus 3. So notice it simplifies, but that still means that x cannot equal negative 3. In fact, when you simplify here, that means you have a whole at negative 3 comma negative 4. That's the point which it can't equal in the simplified version. So we're going to graph x minus 1. So if we put 0 in, we get negative 1. And if we put negative 5 in, we get negative 6. So 0, negative 1 is going to have an open circle. Negative 3, negative 4 is going to have an open circle. And negative 5, negative 6 is going to have a closed circle. So it's going to look like that. Now for the last part, that's a fraction. Remember, so if you put negative 5 in, you get positive 1/3. However, one other thing you know is that x cannot equal negative 8 there. And at negative 8, you're going to have a vertical asymptote. Because that makes the denominator equal 0. Then negative 5 and 1/3, you're going to put a dot here. Or sorry, an open circle, because it's not equal to. You also know that there's a horizontal, so the vertical asymptote's at x equals 8, but the horizontal asymptote, if you were taking the limit of this function as it goes towards infinity, well, it would be 1 over sorry, it'd be 0 over 1, so it's going to be y equals 0. So that means, basically, that if you look at this graph here, and you can figure out some things like if you wanted to put in some points like -6, notice it would give you 1/2, and -7 would give you 1, right? So, I put that in the wrong spot because it's positive 1/3. So it's got to go above here, and then 1/2 for -6, and then 1 for -7. So notice it's slowly going up towards this asymptote, and then it'll just keep going up like that. And then if you want to find out what it does on the other side of -8, like -9, well, it would be -1. So that means it would go right here. So basically it's going to go towards the x-axis there and down towards this asymptote here. Because remember, the x-axis, or y equals 0, is a horizontal asymptote because that's the limit of the function as it approaches infinity. So there's your piecewise definition for number 4. So next we're going to talk about some things as how we can write piecewise definitions from looking at a graph. So a couple equations that you need to keep in mind, like for example, if it's a line, y equals mx plus b, and if it's a parabola, the vertex form of the parabola is y equals a times x minus h squared plus k, where the x and y coordinate of the vertex are the h and k. So we'll use that to help us here define functions for each of the following graphs. So for example, here, the piecewise function, and now we have it less than -2, so if x is less than -2, and notice I can take the point here, and if I go to the left 1 and down 2, I get to the next point. So that means the slope, if I go left and down, that's negative over negative. So that's going to be a positive 2 for the slope. Now I just have to find the b, and I can use the point 0, -2, or sorry, -2, 0. So y is 0 when x is -2, and that'll give me what b is. So b is 4. So the first equation is the line 2x plus 4. The second one is a horizontal line, so that's just going to be -2, and that's when x is between -2 and 0. And then the last one is a parabola, and that's between 0 and 2. Fix that. And then the parabola, remember, is in the form y equals a times x minus h squared plus k. Well, here the vertex is 0, 0, so that's just going to equal y equals a times x squared, because k is 0 and h is 0. So now to find the a, we use one of the points, like here it's 2, 4. So we say 4 is equal to a times 2 squared. So that means a is equal to 1. So basically, it's just x squared for that parabola. So there's your piecewise definition for number 5. For number 6, we have a couple more parts to it. So first of all, from -4 to -1, is the first part, and that is a parabola. And notice the vertex of the parabola is -2 and +3. So if it's negative 2, it's x plus 2 squared, and then it's positive 3, so plus 3 for the y. Now we have to figure out what the a is, so we're going to use the point here. We can use negative 1 and positive 2. So we get 2 equals, and here it's 1 squared is 1, so it's a plus 3. So negative 1 is equal to a. So this is negative x plus 2 squared plus 3. Then we have a line between negative 1 and positive 2. Both of them are equal to. So we have a line, the slope of the line, so you go down 2 and to the right 3. So I know it's y equals negative 2/3 x plus b, because down is negative, to the right is positive. Now, to find what the b is, I can use the point negative 1, negative 1, positive 1 to find the b. So it's negative 2/3 plus b. So when I, oh sorry, it was negative 1 for x, sorry. So it's positive 2/3. So when I subtract 2/3, I get 1/3 equals b. So then it's negative 2/3 x plus 1/3. Then for the parabola, if you notice this is only a part of it, you can see the shadow, so the vertex here is 0, 0. So it's a times x squared. Now I do know that one of the points is 2, 2. So y is 2, x is 2. So when you find a, you get 1/2. So it's 1/2 x squared. And this is when x is between 2 and 4. And then finally, it's a horizontal line when it's between 4 and 7. And that horizontal line is y equals 4. So there is your piecewise definition for number 6. All right, so next we're going to get into some graphing, some special functions. So first, the identity function, that's just f of x equals x. So the identity function points are like 0, 0, because basically it's saying whatever x is, y is the same. 1, 1, negative 1, negative 1. So it's just a diagonal line going through the origin. The constant function, that's when it's f of x equals a constant, where c is a real number, any real number. So we'll just pick a constant here. We'll say this is 0c. So then you would have 1c and negative 1c. And it's just a horizontal line when you graph it. That is the constant function. Next is what's called the Signum function. The Signum function basically has 3 parts. When x is a negative number, it just equals negative 1. When x is 0, it equals 0. And when x is a positive number, it's equal to 1. So if you put 0, 0 here in the middle, and then up above at 1, it's going to go to the right, and at negative 1, it's going to go to the left. Like that. That is the Signum function. The greatest integer function, now the greatest integer function basically says if you have this, it's going to equal the greatest integer that's less than or equal to itself. So for example, if I said greatest integer less than or equal to 2.6, that is 2. That's the greatest integer that's less than 2.6. If I did a negative number like negative 1.5, negative 1.5 would map to negative 2. Because basically you round down. You round down to the nearest integer. And so now this function on its own could be infinite. So that's why we put the dots here to represent that we're only going to graph part of it. So we're going to start with it's 2 if x is between 2 and 3, where it's equal to 2 but not equal to 3. It's 1 if x is between 1 and 2. It's 0 if x is between 0 and 1. It's negative 1 if x is between negative 1 and 2. It's negative 2 if x is between negative 2 and negative 1. And it's negative 3 if x is between negative 3 and negative 2. So that's the piecewise definition. And notice we have the dots on both ends because it goes on forever, but we're just graphing part of it. So to graph this, so if this is 1, 2, 3, so at 2, it's equal to 2. So here's 1, 2. And then it's just a horizontal line until you get to 3, and it's an open circle. So at 1, it's a dot at 1, and then it goes to 2, and then you have an open circle there. Let me see if I can make that a little bigger. There we go. And then at 0, it's going to be 0, and then it's going to have an open circle at 1. Same thing at negative 1 is negative 1, and then it's going to go and have an open circle at 0. At negative 2, it's negative 2, and it's going to have an open circle at negative 1. And then at negative 3, it's negative 3, and it's going to have an open circle at negative 2. So notice it's like a step function. These are like stairs on a ladder. That is the greatest integer function. The piecewise function so basically when we graph these, we're first going to want to write the piecewise definition, and then we're going to graph them. So for example, here, this is saying I'm going to take 3 times the piecewise definition of the signum function. Remember, the signum function says it's negative 1 if what's inside here, so now this is x plus 1, is less than 0. It's 0 if x plus 1 is equal to 0. And it's negative 1 if x plus 1, or sorry, it's positive 1 if x plus 1 is greater than 0. And then you have to subtract 2. So then if I multiply all these by 3, so I get negative 3 and if I simplify this, x is less than negative 1. It's going to be 0 if x is equal to negative 1. And it's going to be 3 if x is greater than negative 1. And then I have to subtract 2. So basically the final piecewise function, negative 3 minus 2 is negative 5 if x is less than negative 1. It's negative 2 if x is equal to negative 1. And it's 1 if x is greater than negative 1. So when I graph this, I put at negative 1, I put negative 2. At negative 1, I also put a circle at negative 5. So negative 3, negative 4, negative 5. And that means it's less than negative 1, so it's going to go to the left. And at 1, I put an open circle, and it's going to go to the right. And there you go. So there's your graph with all the shifting. Same thing for the next one. So here it's -4 times the piecewise definition of the step function. So remember, we need the dots. And then it's going to be 2 if the x plus 1 is between 2 and 3. It's going to be 1 if the x plus 1 is between 1 and 2. It's going to be 0 if the x plus 1 is between 0 and 1. It's going to be -1 if the x plus 1 is between -1 and 0. And it's going to be -2 if the x plus 1 is between -2 and -1. And -3 if the x plus 1 is between -3 and -2. Dots. -3. So now we can simplify by multiplying by -4. So we get 3 dots here. And then we get -8. And then when we simplify this by subtracting 1, we get between 1 and 2. -4 if it's between 0 and 1. 0 if it's between -1 and 0. +4 if it's between -2 and -1. +8 if it's between -3 and -2. And then +12 if it's between -4 and -3. And then -3. So last but not least, you subtract 3. So your final piecewise definition is going to be -11 if it's between 1 and 2. -7 if it's between 0 and 1. -3 if it's between -1 and 0. 1 if it's between -2 and -1. 5 if it's between -3 and -2. And 9 if it's between -4 and -3. Dots. So that's your final piecewise definition. So when you graph this, between 1 and 2, it's going to be at -11. So you're going to have a dot and then an open circle. And then between 0 and 1, it's at -7. So 1, 2, 3, 4, 5, 6, 7. So you're going to have a dot at 0 and an open circle. Connect them. And then at -1, it's going to be -3. Open circle, connect them. And then at -2, it's going to be +1. So then there, connect those. And then at -3, it's going to be +5. 3, 4, 5. Connect those. And then at -4, it's going to be +9, which I believe is up here. It's 5, 6, 7, 8, 9. So it's right here. That's going to be there to there. And there you go. There's your step function with all its parts. All right, that concludes our video for part 2. Part 3 coming up soon.